Ever wondered how your GPS knows exactly where you are? Or how skateboard ramps, roads, and roller coasters all have the perfect angle? Well, it's all about this one thing: slope, the secret language of lines that tells us how steep or flat something really is. Welcome to Module 8, the coordinate plane and slope. Today, we'll explore how to plot points, find slopes, and unlock the geometry behind motion, design, and direction. By the end, you'll know how to plot points like a pro, spot parallel and perpendicular lines instantly, and calculate the slope even from a real-world examples. So grab your pen and paper, get ready to rise and run, and let's make math come alive, right here in Module 8. Fine. So here's the question: how we can find the slope? We saw that when slope means that rise over run. So does it necessarily mean that all the time is going to be like that? What would happen if I do have 2 points and I want to find the slope? Or what would happen if I do have a slope and I would like to find some points? So we do have a couple of very simple formula for that it comes from the definition itself. So when I'm talking about the formula itself, I'm trying to talk about couple of examples. In the meantime, I'm trying to find all of those formulas from one formula in order to you guys to completely understand, because as I just told you at the beginning of this journey, the understanding is the most important part. So let's talk about it. We do have 2 points, -3 and 4, and I do have the second point, 5 and -2. So we know based on the fact that from each 2 points we only have one line that is going to cross. That is a fact. So I do have 2 points, and -3 and 4 and 5 and -2, and I would like to find some kind of slope between these two. How we can draw that? Easy. -3 and 4, we know from that. 3 to the left, 4 to the top. This is -3 and 4. After that, we do have 5 and -2, 5 to the top, -2 to the bottom, and I would like to find the slope of this specific line. How I can use that? As I just told you, M, by the way, is a letter that we call it as in slope. M is equals delta y over delta x. So we know that y means that the difference of y's like this, and x means the difference of x's. So we do have a really some kind of, I cannot say a formula. We do have a way to find that. Y with the index of 2 subtracted with y with the index of 1. What does that? It means that this y is the y-axis or some kind of y steps for my second point, if we consider this one as my second point, and if we consider this one as my first point. And y1 is the y-axis of the second point, of the first point, x2 subtracted by x1. Same scenario, but with x-axis. So at this point, you can see the only thing that I have to do, put some numbers in it. What is y2? y2 is -2. What is y1 is subtraction of itself. What is x2? 5 subtraction of -3. Again, be very careful about the numbers because we are dealing with positive and negative, and sometimes we are dealing with this condition. So we have to make sure that we converting that specific number, so it's going to be negative or positive, and negative times negative obviously is positive, to not get confused and to not get the wrong answer. So on the denominator, I do have -6, and in the denominator, I do have 8 itself. So if I some kind of use, as we know about the simplifying the fractions, if I divide both 1 by 2, I do have -3 over 2, or I do have -1.5. It means that right now the slope is -1.5. So at this point, the interpretation of this one means that for every 4 steps to the right means x1, I have the going down by 3 itself. Please be careful. We do have a pitfall over here. Be consistent with your points. Keep track of which one is x1 and y1 and which one is x2 and y2, because it doesn't matter which one you are using as your first point or the second point. At the end, you are going to find the exact number, which is going to be a negative slope itself. And it's obvious. We are moving from one point to the next one, and your slope is just downward, so it's negative itself. After that, we do have slope from a graph. So right now, here's the question: how I can find, or how I can find the slope directly from the graph itself. Because for the last part, we had 2 points. So that was simple. y2 subtracted by 1 divided by x2 subtracted by x2. Simple, right? Putting some numbers, finding a slope, bam, that's it. But right now, I don't have any number. The only thing that I do have a line. So this is my responsibility to find 2 points. 2 points is enough. 2 points, put it inside my formula or equation that I have, y2 subtracted by 1 divided by x2 y subtracted by x2, and find the slope itself. So let's see at this example and let's follow the steps. So the very first step is that we have to choose 2 points. Again, two whatever points that you need. Again, be careful, those 2 points shouldn't be the same, obviously. For instance, one is A and another one is B. So we had 2 points. So right now we have to count the rise. Rise means that whatever is happening to the y-axis from A to B, if I just count that one, I do have 6 steps to the top. It means that I have 6 as rise. And after that, you have to count the run. Run is x-axis. And from here to here, I do have 6. So that's simple. The delta y, or rise over run, is 6 divided by 6. It is 1. That is how I can find my slope itself. That was simple, right? So let's look at our graph or our line through different kind of points and from another perspective. So we talked about it that we can find the slope. We have 2 points finding the slope. We have a line. We can find the slope. But here's the question. Do I really need all the time to know slope and 2 points and that's it? I should use it more, right? Imagine that I'm asking you, there is a line, and I would like to you guys tell me, if I move 4 to the right, what is my y-axis right now? So right now you need a formula, you need equation, or you need something related to line. You need something to resemble the line, and that's why we call it as the sign of this equation, which is related to y as our rise, to x, which has a run, m, which is the slope, and another teeny tiny new thing that we call it as b, or intersection with the y-axis. So enough of talking, let's see what's happening over here. We do have this formula that y equals mx plus b itself. So at this point, I can resemble or I can replicate any line with this. As you can see, y is my y number or y units. X is my x units is our run. M is the slope and B is what? B is the intersection with y-axis. What does it mean intersection with y-axis? As you can see, let's just go look at previous example. As you can see over here at this line, we do have one specific point that my x is going to be 0 and y is going to be a number. That is the intersection with y-axis, and it is important. Why? Because this specific point is going to show you the difference of that blue line with this red dotted line. Because these two lines, if you assume that they're parallel, we will talk about the parallel, by the way, these two lines are the same, except they're going to be different with their intersection. One, it has the intersection of 0. Another one has the intersection of 2 itself. So at this point, we are trying to see that how we can use them, actually. We can use them in the equation itself because I'm going to need it in the future. Another thing that we can see is that how I can have a point and after that find the second point with only just having the slope itself. Do you guys remember for m we had the formula? Delta y divided by delta x, or y2 subtracted by 1 divided by x2 subtracted by x1. At this point, my second point is unknown. So it means that I don't know anything about it. It's just y and x. I don't know anything about it. So how I can find it? Let me just use another color. I do have my slope is known. I do have my some kind of first point y, it's known. I do have my first point x1, it's known. And I can find a relationship between y and x for the second one, which is going to be something like this. By using that, I can find any point that I like itself. So far, we had a couple of new definitions. The definition was about the slope intercept for it was about the point slope form. Again, these two things are so simple, are so like each other. By the way, these two guys are completely related to each other. Using some mathematical formulas, you can find one from another one. So this one, and at the end, we do have the vector view, which again, it's going to resemble the M itself, so it's not that kind of important thing. And on the right side, we do have different ways of visualization, so you can look at it in order to understand it better that what is going on itself. So another thing that we have to talk about is about parallel versus perpendicular. What does that mean? Imagine that you do have two lines. By the way, you know parallel, right? So when we are talking about the rails of the train, both of them are parallel. It means that they're moving side by side each other. They're not going to some kind of intercept together. By the way, at this point, they are going to, but this is because of a perspective, but they're not going to touch each other at all. So when you have two lines that they're not touching each other at all, or they don't have any intersection, we call those lines as perpendicular. On the other hand, when we do have two lines that they are just kind of have intersection, or the angle between them is going to be 90 degrees after intersection, let me just show you like this. This line are going to be parallel because they're not going to touch each other. And this line are perpendicular while we know that the angle between them is 90 degrees. So when we do have the parallel line, it means that they do have the same slope. They are not going to never meet each other. If line 1 has a slope of m, the second line is also have the slope of m itself. It's a fact. On another hand, we do have perpendicular line. It means that their slope are negative reciprocals. It means that if you multiply m1 by m2, your final answer is -1. Imagine that I do have a line that is going to be 2. The slope of that line is 2. What is the next line, or what is the slope of next line should be in order to make sure that these two lines are perpendicular? The next one should be -1/2, because if you multiply these two guys together, you do have -1 itself. So it is just about the proof itself. You can read it out about that one, but right now we're not going to worry about it. So the only thing that we are trying to talk about right now is about the parallel line and perpendicular one. So when we do have one line and both of them, when another line, both of them, they you have the same value of slope, it means that they are parallel, while if we are multiply them together, m1 and m2, and we do have a -1, it means that they're perpendicular to each other itself.